Hello everyone and welcome back to another video. Just as a heads up, today's video will be working a little bit differently. So instead of explaining the lesson and writing it as I go, I've already went ahead and drawn out all the steps in all the different translations as well as the different graphs. So I unfortunately had to go ahead and do this beforehand due to some technological issues on my end. So I apologize in advance for that. However, I will still be going over the detailed step by step process for how to graph log functions. So now that that's out of the way, today's lesson will be looking on how to graph log functions. So we'll be learning how to graph the log function f of x as well as the log function of g of x. So when graphing these functions, we should first start by graphing f of x. And we do this because f of x is essentially playing the role of the parent function in this problem. So in other words, f of x is equal to log base 2 of x. So we would graph that first because if we look at g of x, that same base or that same foundation log 2 of x is also the same in g of x. However, the only difference with g of x is that it has two translations. So, for example, I went ahead and labeled it there. As you can see, the 2 means you go up 2 and the x minus 3, and the negative 3 means that you go right 3. So notice how in the parentheses x minus 3, even though it's a negative, you would go right. So in most cases, so if it was outside the parentheses and it was where the 2 was, let's say, it would have been essentially left 3 because it's a negative. However, because it's in those parentheses, we're going to go ahead and do the opposite of what the sign says. So we're going to do right instead of left, even though it's a negative. However, if we look at the 2, we're going to do what the sign coincides with. So we're going to go up instead of down because 2 is a positive and it's outside of the parentheses. So the first thing we're going to do is graph the parent function, which is f of x is equal to log 2 of x. So a good rule of thumb to go by is the set of points or the table I've created on the right hand side. We can see the x and y table where I've labeled the y coordinates as 0, 1, 2, and negative 1. And those are generally the points I always refer to when looking for points to graph. And the coinciding x coordinates would be 1, a squared, and 1 over a. So what I mean by a is, in this case, it's going to be 2. So when we look at the table below it, we have 0, 1, 2, negative 1 for the y coordinates. And then for the x coordinates, we went ahead and just plugged it into the x coordinates as seen in the top table. So we have 1 so it's going to be 1 comma 0, as we can see on the orangey red line graphed there. And we're going to do a comma 1. So a in this case is again 2, so it's going to be 2 comma 1, which we can see graphed on the orange line with the blue dots. And then we're going to do a squared comma 2, which is 4 comma 2. And then 1 over a equals negative 1, which is going to be 1 over 2 minus or negative 1 for the last coordinates for the parent function. So we can see how I graph the parent function, and it's going to be the orange and red line. So the next thing we're going to do, or sorry, excuse me, that was the parent function, which is f of x. So now we're going to graph the g of x function. So taking into account the two translations we went over beforehand, which is up 2 and right 3, we're going to do step by step the translation. So the first one we're going to do is right 3. So in the green marker, you can see me going right 3 from the blue points marked on the graph. So we went right 3. And then you just graph all those points. And then after, you can see in the purple marker how I took those points and I just moved each point up 2. And that's going to be our final graph in purple. So we're looking at this final graph in purple. We know that the asymptote is x equals 3. So in other words, we know that the purple graph can get as close to 3 as possible, but does not actually pass x equals 3, which means it's our asymptote. We also know our domain is going to be 3 comma infinity, with 3 having an open bracket because it's not going to reach 3 again. It's just going to get super close, but it's not going to hit 3. And it's going to extend all the way to infinity. And then for range, it's going to be negative infinity to infinity, or in other words, all real numbers, because the purple graph can extend upward and downwards for infinity. So that is how you graph those two log functions. And I apologize once more for having the different setup. But I hope you guys enjoy this video and learned how to graph these log functions.